Lesson 13.11 is plotting points and graphing exponential functions from a table. It says graph the function y equals 2 to the x minus 4 power minus 5 using the given table of values. Plot at least 4 points that have integer coordinates. Integer means a whole number. Could be positive, could be negative, but it can't be a decimal. So what they're going to do is have all three of these tables side by side. I couldn't fit them on here like that, but look at the x values. They're starting at negative 10. The y value with it, look how crazy of a decimal that is. Negative 9, negative 8, negative 7, negative 6 are all very, very, very close. Negative 3, negative 2, negative 1, 0, 1. So we're getting a little more normal here. When x is 2, we're at negative 4 3/4. When x is 3, we're at negative 4 1/2, getting more normal. Not until x is 4 do we get an integer y value, a number that's not a decimal. So I'm going to plot 4, negative 4. Oh, here's another one. 5, negative 3. 6, negative 1. 7, positive 3. And 8, 11, I can't really fit, but I'll put it off here. So you would only need these 4 points. Then it's going to want you to sketch the graph. So this here, this dashed line is called an asymptote. That means my function gets really, really close to it, and it gradually is going to go up, and you got to make sure you're going through all the points. So it gradually spreads to the right and goes up really fast. Okay, I like these because the table is right here in front of your face. You know that when x is negative 10, we're at negative 4.999999939. So we can see that's really, really close to negative 5, but it's not going to get there. Then we're like really, really close. Now this is an 8 and 7, 9, so we got a little bigger and a little bigger and a little bigger and a little bigger. And then at 2, positive 2, we're at negative 4 3/4, which is here. At x is 3, we're at negative 4 1/2, and then that's when we start to really jump. That's what exponential functions do. And then the vertical distance gets farther and farther apart. Like this distance here is going up 1. This distance is up 2. This distance is up 1, 2, 3, 4. It's doubling every time with the distances, right? We're going to this height, and that should be 8. So it goes 1, 2, 4, 8, doubles. But anyways, our asymptote is this equation. So it's horizontal line, it's cutting through the y-axis at negative 5. Where else do you see that in the equation? You see it right here. This was our transformation rules. When there is a function, so like f of x is our function and it's a minus 5 at the end, that means the whole thing moved down 5. So our parent function, which is normally having the asymptote here on the x-axis, got shifted down to where now it's here at negative 5. So that'll help speed you up as well. Okay, there's one more problem on the back, number 2, or the next page. We've got a new function. The base is a fraction, which is okay. We see that it's minus 1 on the end. So that actually tells me right away where my asymptote's going to be. Because normally, like I said, it's going to be on the x-axis. Now we're shifting it down 1 unit. So it should be here. Okay, let's find some integer points, meaning the y values cannot be so big that they don't fit, and they can't be decimals. But read it. So at negative 10, we're at 4,000. Think how high that is. And then it's coming down and down and down. Now we're getting a little more normal. Not until x is negative 1 do we get a number that we could fit. They're at 7. 0, 3, 1, 1, 2, 0, 3, negative 1/2. I know that Delta Math wouldn't want you to graph it, but I'm showing you. 4 is negative 3/4. And then see how we get really, really, really close to this line here, which is negative 1, but we're not actually going to touch it. So then you would graph it like this, and this would be called exponential decay because it goes from a really big number as your y, and then it decreases really, really quick.